Today we look at Wan 2.7, the video model Alibaba's Tongyi lab released on April 6, 2026, and specifically its thinking mode. This feature runs a 4-step internal chain of thought before any frame is generated, reportedly improving character consistency, color precision, and narrative coherence. It builds on a 27 billion parameter mixture of experts backbone, outputting 1080p at 30 frames per second. In the next few minutes, we cover what thinking mode does, how it reasons, and how to prompt for it correctly. Let us start with the core idea behind how to implement Wan 2.7 thinking mode. Here are the essentials of how to implement Wan 2.7 thinking mode in plain language, what it is, and why it was introduced. Thinking mode is Wan 2.7's reasoning layer, released April 6, 2026. Before generating, it runs 4 internal steps, so the model plans the shot first instead of translating text straight to pixels, trading longer generation time for coherence. The first step is prompt analysis. Wan 2.7 maps both your text and any reference visuals into a single shared latent space, so subject, scene, and instruction are interpreted together rather than as separate, disconnected signals. Step 2 plans composition, deciding subject placement, camera angles, and lighting. Step 3 is reasoning verification, checking that the plan stays internally consistent before the model commits any compute to actually rendering the video. The fourth step is verified generation. Wan 2.7 produces 1080p at 30 frames per second, but only after passing verification. This is what reportedly reduces wasted generations from inconsistent characters or drifting color. Now let's look at how to implement Wan 2.7 thinking mode matters in practice. Here is where how to implement Wan 2.7 thinking mode shows up in real products, teams, and decisions. Because Wan 2.7 verifies its plan before step 4, it reportedly catches inconsistencies that normally force a reroll. We pay slightly longer generation time once, instead of regenerating a clip 3 or 4 times to fix drift. To use it correctly, we feed the composition stage real material. Specify subject placement, camera angle, and lighting in the prompt. The clearer step 2's inputs, the more reliably the 4-step chain holds character consistency. The same 27 billion parameter mixture of experts backbone handles text to video, image to video, reference to video with voice cloning, and instruction-based editing. We can switch modes without changing models, keeping reference to video voice cloning consistent across a project. Wan 2.7 is available via API, reportedly from around 10 cents per second, and according to several sources, the weights are also published under Apache 2.0. We budget thinking mode for shots where consistency matters most. Let us recap the key takeaways on how to implement Wan 2.7 thinking mode and what to do next. Wan 2.7 arrived on April 6, 2026 from Alibaba's Tongyi lab. Its headline edition is Thinking Mode, a reasoning layer that plans a shot before generating it at 1080p and 30 frames per second. The 4 steps are prompt analysis into a shared latent space, composition planning, reasoning verification, and verified generation. Each step exists to catch problems before compute is spent on the final clip. We get the reported gains in consistency and color precision by prompting explicitly for subject placement, camera angle, and lighting, giving step 2 the concrete inputs it needs to plan accurately. A single 27 billion parameter mixture of experts backbone serves text, image, reference, and editing modes. The API reportedly starts near 10 cents per second, with weights reportedly published under Apache 2.0. We have walked through how Wan 2.7's thinking mode reasons in 4 steps and how to prompt for placement, camera, and lighting so it actually cuts wasted generations. Try it on one consistency critical shot and compare it against a standard run. For more information, visit Standarity.com. See you in the next video.